All right. Hi, everyone. Welcome to our booth talk about AI-powered automation for all-size machine shops. My name is Vivek Srivatsa. I am a sales account executive at Intrinsic.
My name is Nick Tonti. I'm the National Sales Manager for Trinity Automation.
So today we're going to be talking about a few different topics. We're going to be talking about robotic adoption in machine shops and how the high mix bottleneck is actually a barrier to adoption in machine shops so far. We're going to talk about how our companies are addressing that problem today through physical and AI-enabled CNC machine tending. I'm going to share some stories from the field, quick wins from our customers, as well as the major benefits that they're seeing. Then we're going to introduce the concept of the machine shop of the future and how AI-enabled CNC machining fits into that. So first, I'm going to put up this chart here. This is the percentage of CNC machines in 2024 that were shipped with robots. And you'll see the world average is 12%, which is pretty low. And even more concerningly, the US lags behind most other countries that's nearly 0%. So, Nick, why, from what you've seen in the industry, why do you think that is overall, low world average, as well as why is the US such a laggard here?
Yeah, I guess I can't answer 100% the reason, but what I've in some of the shops I've been in and actually work for what we call the National Tooling Machining Association. I'm on the board of that in Southern California, and what we really noticed is that a lot of times we've lacked behind in the United States when it comes to preparing the next generation. Some of the trades that we used to invest in are gone, and so what we're starting to see, the lack of that it's not coming into the machine shops where you'd expect it to. So there's this skills gap that they talk about. It's a real thing, and it's in most machine shops that we're in that we're not seeing those workers. So I think that's where we're seeing reflected in the numbers. Well, to answer your question, I'll stop because I keep losing my mic.
Sure. So there's a skills gap associated with actually being able to make these robots work and deploy them in production. Of course, programming robots is a skill. People often go to years of school to learn how to do that. When you're programming robots for new parts, you also lose production time. All of the programming happens while the system is down, while the production is actually down. So you're losing spindle time. There's also a cost associated. Every single new part you need to introduce, there's fixturing to hold that part. There's fixturing to grasp that part. All these things that take cost and time to engineer and produce. So, there's really, when we go into shops, we see that robots work for one part, but as soon as the part changes, the robot ends up sitting on the shelf. And so really there's this high mix bottleneck that occurs. Every time a new part gets introduced, we don't have the skills, we don't have the cost, we don't have the time to reprogram the robot to make it work for those next parts. So what Intrinsic and Trinity are doing together is we've collaborated to develop a next generation CNC machine tending product to address this problem. It's called the Trinity AI. It's intended to solve the problem of automating high mix production. So Nick can start off by kind of describing it from a physical standpoint, and then I'll describe some of the software capabilities behind it.
Yeah, absolutely. So if you saw the picture, what we're trying to do, kind of rethink about the way we approach this machine tending problem. The Trinity systems for a long time have been really focused on our pallet systems, but now we're trying to move to parts in a high mix environment. And what that means is how do we make that happen? By making that happen, what we've tried to do is think about that in a different way. So we're trying to think about that instead of necessarily a robot standpoint. We're trying to think about it of how do we make a robot tending solution that isn't driven by the typical integration? How do we start to use software to solve some problems? But we're also looking for things like being able to use machinists to machine soft jaws or machinists to machine fingers, things that they know how to do that don't require an expert robot programmer to be able to help with the integration.
Intrinsic is a software company. We're developing a software platform, a software and AI platform for industrial robots. The Trinity is an expert in CNC machine tending robotic integration. And so they handle a lot of the physical and the hardware engineering side, the on-site service, installation, and helping customers through the applications. And Intrinsic is really focused on the software and the AI. And so what is that AI that's in this product? What is that physical AI that is in this product? Well, the first building block is this concept of AI perception. This means that when a part is loaded onto a tray or some sort of picking surface, you don't need to fixture it anymore. You just use a camera and immediately detect that part with just a CAD model upload. So there's no more need to create any structured fixturing. Fixturing cost goes down. You don't need to take any time to create trays and grids and all of that. From there, you have to figure out how you're actually going to pick up the part. Historically, that's required an engineer, a robotics engineer, to go in and manually annotate the grasp. Intrinsic has automated grasp planning through the CAD upload of the part and CAD upload of your grippers. Our software automatically figures out how to grasp that part, completely removing the need to do any sort of manual grasp annotation. From there, you need to figure out how you're going to get the part into the CNC machine. You got to make sure you're not going to collide with anything. Our software does that automatically as well through the buildup of a digital twin with all the CAD models of the parts, the CNC, the robot work cell. I think Nick has a good example for the first time he saw our automated motion planning capabilities working in real time that I'll let him share really quick.
Yeah, as a robot programmer for years when I was doing installations, the hardest part that we always run into when we're doing a custom automation integration is what we call the error recovery. So it's a fairly simple process to teach a robot to go from one location to the next, but we're always trying to figure out what happens if somebody hits an e-stop or the power goes out or something happens in the middle of an operation. How do we recover? And so that's when I saw the real magic of what happens between the automated, the motion planning. When we got into a situation where the robot was in the CNC machine underneath the spindle and we stopped the robot, hit an e-stop, typically my guys were doing programming would take them 40 or 60 hours to figure out how to do motion planning and recovery to bring the robot back out. So when somebody hits a button to remove it, it comes out. And so when we saw this the first time, they said, "Oh, just hit the reset." And I'm like, "What do you mean just hit the reset?" Like, we haven't programmed any of that. They said, "Hit the reset." We hit the reset button, and to watch that robot back itself out of that CNC machine without any program and go back to home was when I was like sold on the fact that this motion planning is really the way of the future. So that's the real world example of what I saw when I saw that happen.
So every single machine tending product is integrated with this motion planning capability as well, which removes the need to do any sort of explicit motion programming. Then finally, of course, you need to figure out how you're going to get the actual part into the work holding assembly. And we have advanced force insertion and force sensing capabilities to properly seat a part and accommodate for any special alignments and orientations in the work holding as well. So it's physical AI. What does it actually mean when you're trying to introduce a new part? Well, when you're actually setting up that new part, when you're actually setting up that new job, you don't need to do any more robot programming. You can configure your jobs completely offline, so you don't need to take down production. All you do is upload a CAD model of the new part that you want to make, and the software platform handles the rest. The robot figures out how it's going to grasp it, how it's going to move it into the CNC, and how it's going to place it into the work holding assembly. Then once the machining process is finished, it'll do the reverse process. The entire system is also incredibly intuitive, so it doesn't require any robotics expertise to use. It can be done purely by CNC operators that are at every single machine shop on the floor. You don't need any experience with the robotics to be able to run this end to end. Then, of course, you're going to get the robotic consistency and the error handling that'll keep production going once you've set up your parts. So the big benefits that we're seeing from this are, number one, spindle utilization. When it comes to the shifts that a machine shop are running with people, you're going to get increased machine utilization. Today, for the most part, machine shops are only experiencing about a 25 to 30% machine utilization, even during manned shifts. That's because people are taking breaks, they're getting sick. Every time a part is finished running, there's no one to load the next part into the machine. All these things because right now, today, people have to load parts into the machines. Robots can do that fairly simple job by themselves. And then during unmanned hours, you get additional runtime through this automation. So set up a new job at the end of the day, you're going to get additional hours at the end of the day into your night shifts without any people having to be there as well. So what we've done here is we've reduced setup time so that you can start running production batches with automation as little as 20 parts, and we're enabling the accelerated amortization and ROI of the equipment itself. And then I'll let Nick talk about upskilling the workforce, because that's kind of the other core benefit we're seeing from our customers.
Yeah, and again, this kind of goes back to what we were talking about a little earlier, that skills gap. So what we're trying to do is try to optimize and be more efficient in the machine shop with essentially less people, less skilled operators. So what we're trying to do is kind of upskill the workforce that we're trying to utilize to do some of this work. And so what that means is training. We're seeing the ability to take a standard operator who knows how to run a CNC machine, knows the process, knows why it works, knows how it works, but maybe we're trying to get them more skills to be able to run some of the programming or the job setups instead of just standing there all day loading a machine. The other piece that's really important with that is that we feel like once you take that step, we can start to move operators from standing in front of a machine and pushing a button all day long to actually kind of managing multiple cells. So becoming more efficient. And any machine shop that you walk into, what you'll hear every machine shop owner or every operator in there will say, we have to have a person here because when you're running a machine, if for some reason something's not right, you can hear it. And maybe you don't know that if you haven't been in a machine shop, but you can walk around a machine shop and you can hear those machines humming all day long. And when something goes wrong, you can hear it. What a robot can't do is hear that. And so we're looking to say, maybe let's put this operator in the machine shop and he's managing these multiple cells, being more efficient, but still listening, still waiting to hear to make sure things are running correctly. And so we think that if we can upskill the workers to actually start to manage cells and actually start to do setups and do some actual CAM programming, we can start to get more efficient and start to close that gap a little bit.
And the other thing we're hearing on the workforce side is, a lot of these machine shops they're small to medium-sized businesses, a lot of times family-owned, and some of the owners of those machine shops they're getting older, they're looking at a succession plan, and what they've been telling us is it's hard for them to get their kids and other kind of younger workforce into the shop to take over, to be interested in running this. And AI and robotics is actually a way that they can do that. It's new technology, it's interesting technology, and it's actually getting a new generation of the workforce interested in coming back into the machine shop and engaging with that technology. So those are, we've heard that from several machine shops. It's kind of a very, very poignant story. The next thing we want to talk about is the successful adoption playbook for physical AI. So these are stories from the field, from our customers that we've deployed systems for, that we've been working together with, and that have had success stories, and some of the things that they're looking at and the ways they're approaching this to successfully adopt the technology. So let Nick start with the first one.
Yeah, just one example of what I've seen a lot of times. I've been integrating robots for going on 25 years. Worked for Fanic for a few years, been going to a lot of shops, and every time I go into an application with a customer, the first thing they ask me is, we need to automate this process, and they come to me with this list of obligations of what they want to do, and the scope is so big that you're just like looking at this, and by the time you get through to like something that actually makes sense, the price point gets so big that they don't even want to go with it. So you got to start with the basics, and that's the thing we always go to, the easy parts. So in a machine shop, what that means is let's not focus on the really high dollar, really expensive parts that take 4 and 5 hours to run on a machine. Let's start with the most everyday tasks. And the one that's the easiest for me to explain is when you go into a machine shop, you got a 5-axis machine running. Parts may run for half hour, 45 minutes, an hour, 4 hours, whatever it is. But if you look over to the other side of the machine shop, you've got multiple 3-axis machines, and every one of those machines has a person standing there pushing the button, putting a part in, pulling it out, spraying with an air gun, pushing the button. Every 15 minutes or so, even 15 minutes, they're loading a part. And so to us, that's where the key to this is starting is. We're looking at the simple parts, prismatic shapes that we call dovetails, prep ops for the higher dollar parts. Just kind of focusing on things that are small, easy to get wins at, lower cost, that starts to get some momentum into your shop, and you can implement those right away, as opposed to having long drawn out processes with long integration cycles and customized work. So that's kind of my take on how we start simple.
Yeah, so the second point here, stabilize the process first, optimize later. So if anyone in the crowd here has experience with automation or has deployed automation before, or even if you haven't, you've probably heard this term before. Make sure that your process is stable before you automate it. But what does that mean? So an example of this is, if you don't yet know how you're actually going to make your part, don't try and automate it before you've figured that out. Figure out how you're actually going to make the part. Figure out your CNC program. Figure out what machine you're going to make it on. Figure out your work holding assembly. Figure out all of those specifics of the actual manufacturing, and then deploy your automation. Don't try and do those simultaneously, because one, the automation and the machining, the people involved with that are going to step on each other's toes. And two, you're not actually going to figure out, you're not actually going to do either one properly. And everyone's going to end up frustrated. So, figure out your setup, prototype your setup, run your first articles, figure all of that out, and then go and try and automate it. And of course, engage your automation vendor or who your provider is early so you understand if there's any changes that need to be made so that you can successfully automate, but don't try and do both at the same time. Then optimize later. So if you're still early in your automation journey, you're initially deploying automation, don't worry about shaving off cycle time. Don't worry about fully optimizing throughput. You're going to get the additional machine utilization and spindle utilization just from deploying automation. Don't worry about shaving off a couple additional seconds of cycle time through the automation solution. The benefits will already be there just by deploying the automation, especially for a high mix process. The third point here, embrace today's technology. Don't wait for a silver bullet. So AI and physical AI-enabled CNC machine tending exists today. We have a product that we've developed. It works. We've deployed 20 of these systems out in the field today. It works. Don't wait 5 years for whatever, a humanoid technology or something to do a 10 operation part or something that can do the most complex part, because you're just going to miss out on 5-10 years of productivity gains that you could realize immediately. Embrace the technology that's already there, whether that's CNC machine tending automation or AI for CAM programming that you can use for quoting processes. There is a lot of technology out there already that can help you in your shop. And then finally, document and train. So, it's not enough to have just one person at your shop that knows how to use the robotic systems. You want to have multiple people at the shop that know how to use the robotic systems. You want to have some redundancy built in. You want to have one person that can train other people. It's not enough to have one person. Ultimately, there's probably 20 different people at your shop that know how to do CAM programming, that know how to operate the CNCs. There's no reason why there shouldn't be the same number of people at your shop that know how to operate your robotic solution as well. And so this kind of fits into an overall concept of the machine shop of the future. So if you think historically with machine shops, they've been very rigid. There's all the equipment there is hard-coded. The batches are run in high volumes. There's large batch requirements. It's very hardware focused. With this move towards shorter delivery times and shorter batches, there's a need toward this concept of the machine shop of the future. And what is that? It's something that's much more software defined. There's much more process automation. Data can be shared between individual modules. And we can eventually get to this idea of smaller batch production where the entire process is traceable. I think both Nick and I have kind of examples of how this concept of the machine shop of the future actually works in reality.
Yeah, one of the things that we deal with all the time, which seems so elementary, but it's just as much as creating a tooling library. So every time I go into a machine shop that Vivek is talking about, kind of an older machine shop, you walk in and they're going to do a job setup. They'll set up the fixturing, they'll indicate it on the table, we're all good. Then they'll come out with a cart and they've got 50 tools and they're swapping out 50 tools and taking out 50 tools. Well, most likely at least 10 of those tools are the same. And so we start to create this software package where we say, okay, instead of having the rigid way we've always done this, we're always bringing a cart, we're always setting 50 tools. Okay, we're going to keep the first 10 of that library the same. We're going to have the software smart enough to know that those 10 are always the same. We're going to have probes in the machine so we can verify that we have the correct offsets, and then we're going to use those so that we're going to tell the operator, now, in this software, in this setup, you need to pull out tools number 17, 18, 24 and replace them with these tools so that we can actually machine the parts, so we're not spending an hour loading parts. We're spending maybe 5 minutes loading tools. Sorry, so that's kind of what we're looking at. How do we rethink things? Instead of thinking about our standard process, the way of doing things, we're trying to utilize some of the software techniques in order to enable the process rather than enable the routines. That's kind of where I see it in the technical day-to-day world.
Yeah, and so what we've talked about for the most part of CNC machine tending or AI-enabled CNC machine tending, it's basically one module of that machine shop of the future. If you think about the entire chain, there's order intake and quoting that occurs, and there's automation that could be implemented there. There's AI you can use to do your actual quoting as well as your CAM programming. There's already software tools out there that can do some of that quoting and CAM programming for you. Then you move into the actual physical processes. So like we've discussed CNC machine tending today, there's adjacent processes to that as well. Inspection, deburring, material removal, all of those sorts of things. Then there's parts delivery, there's packaging, other things that can be automated. There's material movement through all of those processes with AMRs and other methods, other automation methods. And then there's the entire orchestration layer and the data traceability through that. How do you share data between modules? How do you turn this all into a closed system? How do you, based on the output of your inspection program, of your inspection reports, then inform how much tooling wear has been is occurring in your machines, and then build in redundant tooling, and then potentially even tend your replacement tools. So how do you turn this into a closed system? It requires us moving the machine shop into more of a software-defined world. And we're just at the beginning of that journey, but we definitely see this accelerating over the next coming months and years.